Greetings and welcome to Astronomy 104 at HAC. One of the things we're going to be studying over the next couple weeks is a very important diagram in astronomy called the Hertzsprung-Russell diagram, or HR diagram. And I'm going to go through an example here that we will do in class as well, but this way you have a way to go right back to it and review. And what we're going to do is we're going to make an HR diagram. And we're going to start by drawing the axes. HR diagram is a graph, so we're going to start by drawing the axes, a y-axis, and then an x-axis. And then what we have to do is determine what the components are that go on each axis. And there are several things we can plot each time. We plot essentially on the x-axis. We're going to be plotting temperatures. In one way or another, we are going to be plotting temperatures. And on the y-axis, we are going to be plotting luminosity. We plot those two, but we can plot them in a number of different ways. Temperature doesn't just have to be temperature. And just to be careful, when we plot temperatures, astronomers plot the temperatures backwards. So hot temperatures are over to the left, and cold temperatures, or cool temperatures, are over to the right. So the hotter stars are on the left and the cooler stars are on the right. And we just have to think of that in terms of the numerically. You're going to have the big numbers are going to be to the left instead of to the right, as you're used to doing in a graph. Now, some other thing we can plot on there that we've talked about a little bit is the spectral type. So we can actually plot the spectral class on the HR diagram. And that, again, it goes from hot star to cool star. So the O-type stars would be off to the left, all the way down to the M-type stars on the right. So again, we're doing temperature is hottest to the left and coolest to the right. Now, on the other thing we can plot for luminosity, the other thing we often plot is the absolute magnitude. Now, the absolute magnitude is another measure of luminosity, but it's in the magnitude scale instead of a luminosity scale. So we plot the absolute magnitude there. The absolute magnitude is how bright a star truly is. Again, not how bright we see it from the Earth. That's one thing we see. But it's how bright it truly is in space. Now, when we take this, and we take stars of all different temperatures and all different luminosities, and we plot them, we don't find them all over. We find that they fall particularly along a very relatively narrow sequence that falls from upper left to lower right. And we call this the main sequence. And that is where the stars, most of the stars, will lie. Not all of them, but most of them will lie along the main sequence. Where else might we find stars lying? Well, there are some stars that fall above the main sequence, up to the right. And these are called red giants. So very big stars. They can be stars that are cooler than the sun, but they're much, much brighter, as we see on our graph here. Very cool stars, but much brighter than a typical main sequence star, meaning that they are giant stars, much larger. And in fact, up above, there's even more stars that are brighter, and these would be the red supergiants. So much, much larger stars. These are where the big stars lie. Up in this upper right-hand corner, we have the very, very big stars. Now, how about small stars? We have small stars on the main sequence down here, and we have bigger stars on the main sequence up here. So there's a whole big range. But then below, we will see another type of star. Below the main sequence, we see some very, very hot stars that are very faint. And these are called the white dwarfs. And they're very, very faint. They're very, very faint. Why are they so faint? Well, if we look at it this way, they're very, very small stars. They're very, very faint, even though they're extremely hot. A main sequence star would be incredibly bright at that temperature. But these are actually very, very faint because they are so much smaller. They're incredibly tiny. And when we talk about stellar evolution, we'll go through these. And we'll talk about them as the dead core of a star, like the sun. Something about the size of the Earth. So incredibly tiny stars. So this is the basics of the main sequence. And again, we're going to go into a lot more detail in it, but we create this in class. I wanted to give you an example here of how we could go about creating it that you could refer to. So I hope this has helped you a little bit. And I say, we're going to be seeing this more and more as we go out through the course. So have a good day, and I will see you in